I've travelled here to Valencia in Spain to meet arguably one of the most important and controversial figures of science in our generation. I am talking about J. Craig Venter. From initial studies looking at the way that neurotransmitters work in the brain, he moved on to an interest in genetics and then genomics. It was a career path that was to lead him in the year 2000 to the White House, where he shared the praise for one of the greatest undertakings in human history, the sequencing of the human genome, unlocking our own genetic blueprint. Despite an undistinguished background as a student, he has become one of the most famous geneticists of the early 21st century. Dr. Venter, it's a pleasure to meet you.
Nice to meet you.
Craig Venter, it's a pleasure to meet you. Your autobiography, A Life Decoded, and one of the stories in it which intrigued me was how you got into medicine and then into genetic research, and that came out of your experiences in Vietnam.
Well, I did very poorly in school and left school at age 17 to take up a surfing career, but interrupted very abruptly by being drafted into the military, because this was at the start of the Vietnam War. And I ended up being a medic in Vietnam, and it transformed my life. You know, I saw the value of education, I saw the value of knowledge. The more knowledge I had, the more lives I could save. Well, being faced with things like that almost on a daily basis forces you to either find a way to think about it or ignore it, and I chose to think about it and try and understand it, and that led to wanting to go into medicine, then actually changing, being really excited about science.
One of the things that comes out very strongly in your autobiography is that you are an innovator in the field of genomics. And I think perhaps the most influential technology that you developed was shotgun sequencing of DNA. How does that differ to what they were doing before?
Well, everybody thought genomes were too large to be tackled as a whole. So it was envisioned to break them into thousands or tens of thousands of smaller projects and distribute them around a country, around the world. For example, the yeast genome was one of the first projects funded by governments. It took over 1,000 scientists over 10 years to do that genome. And we reduced that 10 years and 1,000 scientists to 4 months and a handful of people.
And I mean, I think the original budget for the Human Genome Project, which you were heavily involved in, the old way was $3 billion.
That was just the U.S. budget.
Right.
The U.K. and the Wellcome Trust probably spent at least another $1 billion. We did it in 9 months for $100 million, which is still a lot of money, but compared to $5 billion, that's a pittance.
And you did that via sort of the private route, and I found that very, very interesting. Is that a reflection of the fact that you went to venture capitalists effectively, a result of any disillusionment about the way science was funded?
It was a reflection that we couldn't get the money from the government. They had their bureaucracy set up, and it was only because it wasn't venture capitalists, it was a company that made the sequencing machines that put up all the money more as a test to show their sequencing machines would work.
Is this applied biosystems?
That's right.
And I noticed also in your autobiography, one of the things that you said is that when you set up your various institutes, Tiger and Celera and all the rest of it, the two things that you insisted upon was no tenure, and you wouldn't allocate funding, you wouldn't allocate space on the basis of funding.
Yeah.
And this is still very common in the United Kingdom, certainly in the tertiary education sector.
Yeah.
But what made you go down that route?
Well, it's still very, it's the standard in most American universities as well. It's, tenure used to be something that protected risk takers. Now it seems to be something that protects mediocrity. And so the whole purpose of it has gone away. And in science, your tenure should be the quality of the work you do. And so even Nobel laureates like Ham Smith don't have tenure. We're all at-will employees. I don't have a contract, even with my own organization, because it's the quality. You know, when people do world-class research, that's better job security than any contract you could have with somebody.
Just tell us a little bit, if you would, about how it felt to be in the White House in 2000, because there was a lot, it seems to me, of hostility, shall I say, to the way you were doing things, and perhaps a lot of misinformation about patenting genomes.
Yeah.
And one of the things I get out of your book is that you're quite clear that you never went into it to patent genomes and make money. How did that myth arise?
Yeah. Well, just think if you were head of a multi-billion-dollar government or Wellcome Trust program, and somebody came along and said, I can do your program in 9 months for a tiny fraction of what you're spending, you'd probably be pretty annoyed too. It happens throughout history when people get phase shifted by new thinking and new technology, and they're unwilling to change. So it's unfortunately, I think it's human nature. I'm sure it happened when Henry Ford developed mass production automobiles and replaced horse and buggies. You know, the buggy manufacturers probably weren't too happy with him.
But I noticed that when you went over towards private funding, that came with its own sort of set of problems as well, didn't it? It wasn't like somebody just said, as you I think had hoped, correct me if I'm wrong, Craig, you know, here is the money, just please go get on with it. How was that to work in?
Yeah, there's definitely no free lunch in the world. And, you know, everybody wants something for their money. The foundations and governments want credit. The businessmen want credit and control. So there's trade-offs with every approach, but I think it is pretty extraordinary that private investment money went into the biggest public project ever, made the human sequence available to the world for free. I mean, that's pretty extraordinary. In fact, it turns out private industry does things like this not infrequently. Academics like to think they're the only ones that do anything in that vein. And quite often they block money that goes to innovation. So it's fortunately there are occasionally alternatives for some of us to follow.
Do you think that is your favored approach for the future of science funding?
Well, all the breakthroughs that my teams and I have made have been because we had independent money to pursue it. It didn't matter whether it was ESTs, the first genomes in history that we did, the human genome, what we've done with the environment, and now what we're doing with synthetic genomics. All of those started with some independent resources to prove the idea worked. Once you prove an idea works, it's easier to get government funding, ironically.
Yeah.
So I think I've been fortunate in finding ways to get money to do those pilot experiments to prove that the ideas work. I like to convince people by having the experimental data, not by making arguments.
So you left Celera after the Human Genome Project was completed, and you went to the ocean, which is your other passion, I think, on your yacht Sorcerer II. And it's like a step up in scale, isn't it?
Yeah.
Here is the human genome, now we're going to sequence the planet. I mean, what was your thinking behind that?
Well, we knew that the techniques that we had in the mathematics was able of solving multiple genomic equations simultaneously. At the same time, trying to look around after doing the human genome, myself and my team with Ham Smith and others, obviously we established a certain amount of scientific credibility, and we had the choice to work on whatever we wanted to work on. And I felt and we felt that what we're doing to our environment is the most pressing issue facing humanity. We can't keep doing what we're doing, so we thought maybe our tools would enable us to have a better understanding of the environment and even lead to new discoveries how to protect it better.
How do you see the discoveries that you are making with synthetic genomics actually mapping onto solving environmental problems?
Well, the biggest problem we have is the CO2 building up in the atmosphere, primarily from burning oil and coal. So we're taking ancient carbon out of the ground, we're burning it, and it ends up in our atmosphere. I mean, here we're sitting in this beautiful setting. If things continue the way they go, this will be underwater in the future. With climate change, it's just not a matter of places getting warmer. We're already having food shortages in the world. So this is not an option. I mean, humanity can keep going down this track and slowly destroy itself, or we can use the tools of modern science to try and change the problem. And so we're trying to use biology to come up with new sources of fuel so we can have replacements for oil and coal on a renewable basis.
So is that like moving to a hydrogen economy or something different?
I think it's unlikely we'll get to a hydrogen economy, but I think we'll be in a CO2 economy. We can take the carbon from carbon dioxide and convert it into fuels. I mean, that's what plants do with photosynthesis. Yeah. They convert the CO2 into sugar, which you can then burn, but we're trying to make it much more efficient, going right from CO2 into fuel production. If we can do that, then we have a renewable source.
You are obviously most well known for your work in the Human Genome Project, but something that you did recently has hit the headlines, which is the development of a synthetic chromosome from raw laboratory chemical. Do you see that as part and parcel of your vision for applying genomic science to environmental problems, the ability to create this kind of life?
It's the tool set that will be used by tens of thousands of scientists to solve all kinds of problems, not just the fuel problem, but the entire petrochemical industry is based on taking oil as the raw material, making clothing, carpet, plastics. There's the potential to replace that entire industry, starting with sugar, starting with carbon dioxide, using biology to drive these processes. The ability to now write the genetic code allows us to harness this power in a very thoughtful fashion to change metabolisms of cells to do these processes in very efficient ways. So I think it's essential for the future that this new technology is being developed.
What would you say to the lobby who say that interfering with the natural order of things, which is crystallized in the substance of DNA, is somehow the wrong thing to do? What would your response to that be?
It's not sufficient just to have scientists making the breakthroughs if there's not sufficient education in the public to understand what the science means, what the alternatives are, what are the choices being made. The best science could be eliminated by mindless fear.
There is currently in the United Kingdom anyhow a debate, particularly among secondary school teachers, about how science should be taught. Should we teach science as individual subjects, physics, biology, chemistry, get to know the basics, build up from there? Or there is a movement afoot to try and enthuse students by telling them what science can do. How would you view that debate? What would you say is the most important of those two things to do?